All right, let's get right into it. Today, we are talking about your secret weapon for that GCSE computer science exam. And no, it's not about cramming more code. It's about totally upgrading the way you think.
You know that feeling, right? You're staring at a big 6-mark question, the clock is ticking away, and your mind just goes completely blank. It feels huge, overwhelming, like this impossible mountain you've got to climb.
But what if I told you the answer isn't about memorizing more facts or syntax? What if it's about having the right mental toolkit to take that mountain apart, piece by piece, until it's just a bunch of small, easy-to-climb hills?
Okay, let's dive in. That toolkit, that whole framework for thinking like a computer scientist, well, it has a name: computational thinking. And honestly, this is the absolute bedrock of how programmers tackle problems, and it's a massive part of your GCSE.
So what is it really? Well, it's basically a structured method for problem solving. It gives you a reliable process to follow so you can turn that panic into a solid plan, and all that confusion into a clear set of steps you can actually do.
So let's open up this toolkit, shall we? The very first tool you're going to grab when you see a big, messy problem is decomposition. And just like it sounds, it's all about breaking things down. The official definition is super simple. You take one massive problem and you just chop it up into several smaller, bite-sized subproblems. Each one of those is way easier to understand and solve on its own. And this is just a brilliant way to think about it. I mean, nobody just builds a car, right? That's insane. They build an engine, then they build a chassis, then they do the wheels. Decomposition turns a huge, scary task into a simple to-do list of smaller, totally achievable goals. It gives you a place to start and a path forward. All right, let's grab our second tool. Once you've got your smaller problems, you need abstraction. Think of this as your focusing lens. It helps you filter out all the unnecessary noise. Abstraction sounds way more complicated than it is. It's really just the art of removing pointless detail. In any problem, especially in an exam, you're going to get extra fluff and information. Abstraction is the skill of just identifying and focusing on what is absolutely essential to solve the problem in front of you.
And honestly, the tube map is the perfect example of this. Think about it. It's a map of London, but it deliberately hides all the roads, the parks, the buildings. Why? Because if you're on the tube, you don't need any of that. You just need to know the stations and the lines that connect them. That is abstraction at its best. It makes a super complex city simple enough for its one job, getting you from A to B.
Okay, so you've broken the problem down. You've filtered out all the noise. Now it's time for the final tool, algorithmic thinking. This is where you actually create the step-by-step plan to get it done. An algorithm is just a fancy word for a set of instructions. It's the plan. It's the precise set of rules that, if you follow them exactly, will solve your problem every single time. No guesswork needed.
The classic example is a recipe for a cake. It gives you your inputs, the ingredients, and a very precise set of steps to follow. You follow that algorithm, you get a cake. You write your program's algorithm correctly, you get a working solution. Simple as that. This is the bridge from thinking about a problem to actually writing the code that solves it.
So we've got decomposition, abstraction, and algorithmic thinking. But here's the thing, they're not just separate tools you pick from at random. Their real power comes when you use them together as one smooth process. Let's see how that looks.
So this is the transformation we're talking about. You start with a problem that just feels like a chaotic mess. You don't even know where to begin. But after you apply this toolkit, what do you have? A structured, organized plan. You know exactly what you need to do, what order to do it in, and how it all fits together. It's night and day. And here is that process. Think of this as your 3-step mantra for any programming challenge. Number 1, decompose it. Break it down. Number 2, abstract. Ignore the junk for each piece. Number 3, algorithm. Make the plan for each piece. This little sequence will guide you through pretty much anything the exam can throw at you.
Now, why are we banging on about this so much? Because this isn't just a nice-to-have skill. This is a fundamental and, more importantly, an assessed part of your GCSE, specifically for that computational thinking, algorithms, and programming paper, the J277/02.
If you actually look at the OCR specification, and I know, thrilling stuff, section 2.1.1 is literally called Computational Thinking. And what does it list? Abstraction, decomposition, and algorithmic thinking. The examiners are telling you, straight up, that they expect you to know and use these ideas.
And hey, don't just take my word for it. This quote is pulled directly from the aims of the whole qualification. It's not a suggestion, it's a description of what a successful student needs to be able to do. And this toolkit, this is how you do it.
So the next time you look at a practice paper, don't see an impossible problem. See an opportunity to open up your toolkit. You have the tools. You have the process. The only real question left is, what problem will you solve first?